In episode 25 of Mobycast, we continue our micro-series on Docker tips and tricks. In particular, we discuss how to start up containers dependably and shut them down gracefully. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey guys.
What have you been up to this week, Rich? Besides producing another episode of Mobycast.
Fighting with Facebook ads and trying to figure out how to get some intelligence from what we're seeing on a project that you and I are working on together. We've managed to figure out, so if you've come to this podcast through a Facebook ad, those ads have been working very well for us, and we have those under control and they're pretty predictable. But for another project where we're working on Facebook ads that lead to app installs, it's inconsistent. The data conflicts with each other, and we've been really struggling trying to wrap our heads around it. So a lot of time with that, and then a bunch of different WordPress projects that have been going through. But with all that said, we reached 10,000 listens, 10,000 downloads with episode 24. So thought I would say thank you to those who are actually listening to us. And although we've had 10,000 listens, we've had 0 reviews. And so with that milestone behind us, our next milestone will be the first review. So if you've liked what you've been hearing, give us a 5-star review. And if you don't think we're doing a good job, find John on Twitter and reach out to him there.
Yeah, please do. That's so funny that you said that, Rich, because I was thinking I was going to say the same thing. So yeah, we'd love to hear from you if you're listening. And Chris, what have you been up to?
I am trying to hide from all the smoke that we have here in the Seattle area. So the wildfires have been pretty bad in Canada and the other areas around us, and it's just been sitting over Seattle. So we kind of look like we're on like Tatooine with the red sun and a red moon at night. So it looks like we have some relief in sight, and I will be able to get back on my bike. So looking forward to that.
That would be nice. Eagle has been that way. Eagle, Colorado has been that way all summer. And I recently saw, I think it was maybe on NPR, that large parts of the West have had worse air quality than Beijing throughout the summer, which is just kind of, I've read about bad air quality in Beijing, and I've talked to people that are like, oh, I wouldn't travel to Beijing with my kids because the air quality is so bad there. And it just kind of hits you in the face when you're raising kids and you find out, oh, actually the air quality right here is as bad as it gets. So pretty hard to deal with this climate change and these fires and this awful air.
Indeed.
It's really, really depressing. But
I'm scraping the ash off the cars. So
yeah, exactly. I mean, literally weeks and weeks and weeks of horrible air. So hopefully it gets better. We've actually had a ton of rain here in the past couple of days. So I think we're on the upswing too.
Nice.
And more fun things to think about, Docker and AWS. Let's kind of continue where we left off last week. So last week, we were doing a recap of Tips and Tricks Talk. Who was that by?
It was by Adrian Moat, who's the chief scientist at Container Solutions. And he had a breakout session called Tips and Tricks of the Docker Captains. So talk about Adrian's in that Docker Captain program. And so kind of brainstorming with the rest of the folks in that program that he's familiar with to kind of come up like, what are the kind of common gotchas that folks have that they see do and present those in a session.
Cool. And we talked also last week about how this session is really just tips and tricks, and there wasn't an overarching theme other than here's great things for you to know about. And so each tip and trick is not necessarily related to the next. So we can jump right in. The last one we talked about was beware of latest. We don't need to talk about it again. That's on the last episode. So we can jump right into the next one. What's the next one?
Yeah, so the next tip is start up dependably. And so this is definitely a common situation when you have more than one container that needs to spin up, especially like in your local environment. You're probably using Docker Compose. You have multiple services defined in your Docker Compose, and there's very real dependencies there. The typical example would be you have a microservice implemented an API that uses a database for a backend store. And so obviously the database needs to be up and running before the microservice is. So, you need to kind of manage all that stuff, and make sure that you are starting up dependently. So, what are the gotchas and how do you do that? And so, and again, this is a pretty typical problem that folks have, especially like just, right out of the gate. And there are ways that you can, in your compose file, you can have settings that kind of give hints on for the Docker Compose tool itself of like how it should start things up. And but that doesn't mean that it's actually ready. Just because it started doesn't mean that it's actually ready to service calls, right? So there's this whole synchronization thing. So you have to be aware of that. And one of the best ways of dealing with this is to actually just code this into your dependencies themselves, right? Whether it be, you can either do that in your application code, or you can do it, if you don't do it there, then, maybe you do it in your startup script. So like, again, in this example, if you have a microservice with a backing database, you may go ahead and say, go ahead and start up this database service, start up your microservice. As part of your microservice startup code, it can go query for the database connection, and check to see if it's ready. And if it's not ready, then it just sleeps, and waits a little bit and then goes and checks again. So it's polling, it's waiting for that service to come up and be alive. And then once it is alive, then it can proceed, right? And so again, you can do that kind of that polling for readiness, either in your startup script or in the application code itself, depending on what makes most sense for you. But doing that is going to give a much more dependable operation of your code. And it becomes even more important the more dependencies that you have.
Hey, this is Rich. You might recognize me as the guy who introduces the show, but is pretty much silent during the meat of the podcast. The truth is, these topics are oftentimes incredibly complex, and I'm just too inexperienced to provide much value. What you might not know is that John and Chris created the training product to help developers of all skill sets get caught up to speed on AWS and Docker. If you're like me and feel underwater in these conversations, head on over to prodockertraining.com and get on the mailing list for the inaugural course. Okay, let's dive back in.
So this is causing me to have some thoughts, and I realize that you said that this might be mostly in your local environment, because the thoughts that this is causing me to have is that can't we use our orchestrator to do some of this for us? So, and wouldn't it be better to not have application code sleeping if it's not really working? Because what I'm thinking is you have a container and it depends on a database. It seems like in a perfect world, the container would start up and be like, "Oh, my database isn't there. I'm going away. I'm done. Don't worry about me. I shouldn't be alive." And that the orchestrator should be the one that's like retrying and retrying until it can succeed, as opposed to the application code sitting there with a running container that's doing nothing and not useful, waiting and waiting for a database to come alive. What do you think?
It's definitely pretty complicated, right? Because there's one, like what is your orchestrator? So like in your local environment, like Docker Compose is your orchestrator, right? And so
right.
In this particular case, it could be, you could very well be running Kubernetes or something like that locally as well. And you can use that as your orchestrator. Sure. And there's actually other options out there as well. But, for the most part, if you're a developer writing code, like you're probably going to be using Docker Compose. And so that has some, basic functionality. Again, the whole like dependencies thing, like how do you actually describe those dependencies? And then you get into the concept of like shallow checks versus deep checks on health. Again, like it's one thing to say something has started up and you may have a shallow health check for that, but is it really ready? Like maybe it has dependencies, right? That it has to wait for them to be ready, right? So now you have this, like, do you do a deep check and how do you describe all this stuff to an orchestrator for it to do? And so that's just a lot of complexity. And no one knows that better than you. So it really because so it does kind of get pushed off from the orchestrator back onto you. So the orchestrator can help out a little bit with like, hey, this is the sequence I want things to do. I want to go. But as far as actual really guaranteeing like, yeah, these things are up, they're ready, they're responding to requests correctly, and just making sure that the system's up and running correctly. Like that's more your job.
Right. So I really think this is worth talking about a bit more. So one of the things about Docker is that it's supposed to let you make these containers that are, you run them anywhere. So you run them in production, you run them in staging, you run them on your local machine, and hopefully they're not really different in those different environments. They're just the container is the container, and it's happy to be run in different contexts. So having said that, it feels like, on the one hand, yeah, the container itself and its application code, it does feel like it should be aware of its dependencies. It should be able to say, hey, my dependencies aren't here. That's wrong. Something's not okay. And maybe, one thing is like the container is like, okay, I'm going to wait for my dependencies, or I'm going to give them some time to come up. Or maybe the other thing the container could do is be like, oh, my dependencies aren't where they're supposed to be. So I'm going to tell you as part of my graceful shutdown what I'm missing and why I'm not happy. So that at least you get some feedback. And then the reason I feel like the orchestrator should be part of this is like orchestrators kind of run towards this sort of optimal, and they're trying to make things optimal. So they're like, oh, we want, at least 5 containers running, but not more than 10, or, and that's how you do things like no downtime upgrades. So no downtime upgrades require orchestrators to be sort of smart about shutting down containers and spinning them up and waiting till they're happy. And then if there's ever a container that fails, orchestrators are like, yep, let me just take care of that and put a new one in. So kind of going back to what we're talking about, I agree that orchestrators shouldn't enforce a dependency order. Like the orchestrator is not really going to be in charge of making sure that this one starts and then this one starts. But it may be okay to rely on the orchestrator to keep trying to start something if it's not happy. So if a container is like, I'm not happy, my dependency is not there, then it seems to me to be like that. And that may be a lack in Docker Compose. So the fact that Docker Compose is not really a full orchestrator is kind of problematic, because all the other orchestrators that we use, like ECS or Kubernetes, are good enough to say, oh, I'm gonna retry several times until I get a happy container. And then a happy container is one that says, yep, I got my dependencies and I'm running. As opposed to, I don't have my dependencies and I'm running, so I might seem happy to the orchestrator, but I'm not actually. You know what I mean? That was a long description, but I'm trying to get at something there.
It's a super complicated problem just because of the fact that they're dependencies. There can be multiple ones, and you can have dependencies of dependencies. You can think of it like it's a graph, and you can have loops. And so, even something like ECS or even Kubernetes, I mean, they're not looking at the graph, right? They're looking at just like, okay, here's a container I'm spinning up. Kubernetes has the idea of health checks. So you can actually have Kubernetes health checks in with your services and whatnot. And it can ping that stuff, and it can say, oh, this container's not running, and just go ahead and restart it. But again, if it's not started because this other thing's not ready, and maybe that other thing might be waiting on something else, like it could just be thrashing. Like
right. If that other thing is outside of your control plane, so it's not going to get started. Yeah. No, I think the thing that really caused me pause, the thing that made me like, I don't know if I agree with this, is just the idea of having a container that's sitting there waiting and not telling anybody what it's waiting for. It's just like waiting for a dependency and pulling and not being useful to anybody for anything. That was what made me say, wait a minute, that doesn't sound right. Why would you ever want to have that? I get it in a Docker Compose environment, and maybe the idea is, it's not going to be waiting that long because you know that the Docker Compose script is going to start the other container, and it's just going to take a little bit to start. But if you're not always running in Docker Compose, which you're not, then that behavior is sometimes useful and sometimes really, really bad.
Yeah,
see what I mean?
Yeah, and again, just really, like, this is definitely something that's much more applicable to a local environment, and not in your cloud or your production environment. So, like in this particular case, again, microservice backing database, you're spinning up the database locally on your machine, on demand for that. In your cloud or production environment, it's probably an RDS instance, right? And so it's always there. So there is no, you don't, that dependency it's just there. You're not going to wait for it. So a lot of times you'll do that too, right? This polling code, you'll put in flags, right, to say only do this when I'm running locally. Don't run it in production. There's no reason to. And this goes with just about all your other dependencies as well, right? So it's like when you're running in the cloud in your production environments, like you could have 20, 50, 100 services that are all kind of like clients of each other and whatnot, but they're all actively running. It's not like you're starting all of them every time you deploy something, right? Versus that's what's happening on your local machine. On your local machine, you're probably starting up. You have to start up all your. So this discussion, it really is much more relevant to your local environment when you're running, and then also like in your CI environments, right? So like if you're trying to run test, and that might require spinning up some dependencies, like this really comes into play as well.
Cool, that makes sense. And so can I get at least a nod of acknowledgement that maybe it's in a production environment, it's maybe not a great idea to have application code that just sort of waits forever for inside a container for a dependency to be available?
You will not get just a nod, but you'll probably get a you just like that's verboten. So like if you are if so and that is a really good distinction to make, right? Like again, like that the example of like kind of polling and whatnot being in your startup script or application code, definitely make sure that's for your local environment only. Like guard against that. Cool. Don't do this in production, because if you're doing that in production, then you need to be doing some other things first. Like you're doing something, you're right. Probably doing some things wrong.
Right. Great. Okay. So I think we have just a couple more minutes that we can squeeze in this shutdown gracefully tip and trick, and then we'll finish off the rest of the tips and tricks next week.
Sure.
So what's the shutdown gracefully?
So this is another one of this grab bag of tips, and that is like how do you shut down? Like how do you handle shutdowns in your container? And this is one of those things that I think a lot of people don't give too much thought to, and it's probably it's definitely not top of mind, but it is something to give some thought to understand like what's going on there and what you may be missing out on. So just for reference, when Docker wants to stop a container, right, it's gonna send that container a sigterm signal, and then it's gonna wait 10 seconds for that container to respond to that sigterm to give it a chance to clean up and stop gracefully. If it doesn't exit within those 10 seconds, then it's gonna hard kill it by sending a sig kill signal, right? And so what this means to you in your application is that if you properly handle that sig term, it's going to give you the opportunity to clean up and to make things tidy before you exit. So it might mean things like closing network connections or sockets or handles. Maybe it's like finish writing stuff to a log, flushing memory to a log. If maybe you're doing caching for performance reasons, maybe you need to write some stuff to a database, and whatever else, what other kind of housekeeping your app may or may not have to do. And then the other big benefit, of course, is just faster shutdown, right? Like if you actually respond to it, like your container will shut down very, very quickly, as opposed to just hanging basically for 10 seconds. And I think if you've used Docker and various images and just even on your local machine, I mean, I've run into this many times of using various images, and like when you go ahead and try to stop something, it just kind of hangs for a while before it finally quits. And that's what's going on, is that particular container is not responding to the sigterm signal. So
that is super interesting. I did not know that, and I've definitely seen that behavior.
Mm-hmm. Yeah.
So it's like 99.99% of Docker containers are not using this tip or trick.
Yeah. Yeah, indeed.
Super interesting. Yeah. And like, gosh, that when something does go wrong or when you get shut down sort of unexpectedly, wouldn't it be nice if you have some log buffer in memory to get that written out before things go away?
Yeah, and we've seen this in some of the apps that we've done too, where it's like some of the logging we were doing, the way that the logging code was working, it was not getting a chance to flush when the container was shut down. So like when it had maybe an abnormal exit, or it was being shut down because it failed a health check, it was not finishing. We were not seeing this in the logs, right? And this was
brutal.
One of the reasons why, right? Yeah.
Wow. Well, thank you very much. Those are two good ones. Thank you really to Adrian for coming up with those and letting us talk about them. We'll talk to you again next week with a few more.
All right. Thanks, guys.
Take care. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/25. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.